Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for the math portion of the GRE. We have been solving math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 155, and today is day number 52, lesson number 52. The second problem that you see there on the bottom of page number 152 or 155. They give you a little graph there, a bar graph, which I need to reproduce here, otherwise we won't be able to work. And they gave us 7 intervals. 10, 20, 30. The first one is 15. Second one is 35. The third one is 15 again. The fourth one looks like about 12. Then we have 10, and then we have 5, and then we have the last one. What do you know? We squeezed right in. And since you have the book in front of you, I'm not going to write all the details here, and these are the frequencies. So we have 95 observations. And we are asked to compare. In column A we have the mean versus the median. Or is it the other way around? Yep, the mean versus the median. Let's solve. Very simple, very straightforward question. The question may be very simple, the question may be very straightforward, but the answer, the work that is involved in order for us to be able to answer this question is anything but. Let's get going. What's the median? Let's start with median. Let's start with second column first, which is the easier part. What's the median? Median, if I know how to spell median, I don't know about you, but I'm dreading the whole thing, what is coming up, because if the guy can't even spell median, how is he going to solve the problem? Median is the middle number, after the numbers have been arranged either in ascending order or in descending order. That is the proper definition of median. The numbers have to be arranged either in increasing order, in ascending order, increasing order, 2, 3, 4, 5, 6 and so forth, or in descending order. You can arrange them in descending order also. You can go 10, 9, 8, 7, 4, 3, 2, 1 and just ask yourself which one is the one that falls in the middle. And for number to fall in the middle, you have to have equal number of observations on the left hand side of it and the right hand side of it. For example, if you have 11 observations, 5 numbers are going to be to the left of the median, 5 numbers are going to be to the right of the median. On the other hand, if we happen to have even numbers of number, listen carefully, even numbers of number, for example 3, 4, 9 and 54, 3, 4, 9 and 54, well, there are 4 numbers here. Let's make it simpler first to start out with. Negative 2, 3, 4, 9 and 54. What's the median? Well, the numbers are already arranged in the ascending order, they are already arranged in the increasing order, so the middle number is 4. That's your median. You got two numbers on the left hand side of it, two numbers on the right hand side of it. What happens if we have even numbers of numbers? Something like this. What happens if we have even numbers of numbers? We got 3, 4, 9 and 54. In that case, you take the middle two numbers and you take their average. The sum of these two numbers, 9 plus 4 is 13. 13 divided by 4, that is your median. The median of these four numbers, 3, 4, 9 and 54, is 6.5. It doesn't matter whether it's 54 or 54 million, it doesn't matter. It does not matter whether it is 3 or if it is negative 3 million. If you had negative 3 million and then a positive 4 and a 9 and a positive 54 million, it still would not have changed the median. Median simply means is the number that is sitting right in the middle after the numbers have been arranged in proper order. Well, here all the observations are already arranged for us. If you look at the table there, I don't have the room everything, so I'm not going to try to squeeze everything in here, because if I did that, it's going to look very crowded, it's going to look pretty dirty. It's 1 through 5. The observations 1 through 5 are in the first one, and apparently they had 15 of those. This is a 15 right here. And then they had, looks like they had 35 observations. They had 35 observations which were either a 6 or a 7 or an 8 or a 9 or a 10. And then they had another 15 observations which were either 11, 12, 13, 14 or 15. You get the idea, and so forth. Finally, in the very last bar, it looks like they had about 3 observations which were either 31, 32, 33, 34 or 35. There is no way of knowing what these exact observations are. All we know is that they were somewhere between 31 and 35. That's what the bar shows. So, since we have 95 observations, subtract 1 from it, that's the one in the middle because this is an odd number of numbers. That leaves us with 94. If we divide 94 by 2, doesn't keep listing, okay? If you divide 94 by 2, how many 2s in a 9? There are 4 2s in a 9. The remaining one goes here, becomes 14. How many 2s in a 14? There are 7 2s in a 14. So we are interested in situations where we have 47 observations. 47 observations. To the left, then we got our median, and then we have 47 observations on the right hand side, on the left hand side. And that guy right in the middle, after we have arranged them so that 47 observations are to the left of it and 47 of them are on the right of it, that is your median. Well, that's very easy to find out. Why? Because we have 15 of them here. 15 of them here, and then we have 35 of them here. Right here. Just the sum of these 15 and these 35, by the time you get up to here, by the time you get to the end of the second bar, we have 50 observations. 15 plus 35. Which means that the 48th observation, which implies that the 48th observation falls somewhere in here. 48th observation falls somewhere in here. So this implies that the 48th observation is either 6 or a 7 or an 8 or a 9 or a 10. We do not know. There is no way of figuring it out what exactly it is. There is no other information. So we do know that the median of these observations is going to be either a 6 or a 7 or an 8 or a 9 or a 10. I should have put the word or in between every one of them, just like I did here. I did not because I was lazy. But that's it. We're done with the median. The median of these 95 observations is, one more time, it's going to be either a 6 or a 7 or an 8 or a 9 or a 10. There is no way of determining for sure exactly what the median is. Now we're going to work on the mean. Okay, I'm done with it. We're done with the median. I need the room for the mean, so we get to erase everything. That's it, we're done. Now let's do the mean. Mean is going to require even more work. This problem is, as I told you, is quite involved for somebody who's not familiar with the concept of statistics. Somebody who's not. But the word that comes to my mind is conversant. What does it mean to be conversant? I'm digressing here. Hopefully I spell it correctly. I'm looking here in my list as to when we learned it, because I think we learned this word conversant in one of our vocabulary lessons. And if you don't know what I'm talking about, in addition to the math video that you're watching, I have also put together some vocabulary videos on the YouTube. I cannot find this. Oh, conversant right here. Day number 3. What do you know? Just type in vocabulary day 3 and you will learn this word conversant. It just means to be expert at something, to be good at something, to be skilled at something. If you're skilled at something, if you're good at something, if you're an expert at something, if you have expertise, you're conversant in it. So this problem is not as involved, it's not as bad for somebody who is conversant in statistics. For them it's very simple, very straightforward, and at the end you will see how straightforward it is after we finish learning the whole thing. So here we have 95 observations. Let's find out. Let's see if we can determine if mean, let's see if we can determine if mean is going to be below 6, if the average of these 95 observations is below 6, in which case if the mean is below 6, then it doesn't matter whether the median is 6, 7, 8 or 9 or 10. If the mean is below 6, if mean is less than 6, the answer would be in this case be B, because median we know is at least 6. Or is it above 10? If it is above 10, if the mean turns out to be more than 10, something more than 10 versus the highest it can have is 10, in which case the answer would be A. That's what we are trying to figure out. And if after all the work we still cannot determine for sure whether the mean falls somewhere between 6, or whether the mean is below 6 or above 10, if we cannot figure out for sure, in which case the answer is going to be D, as in David. So what does it mean if it were below 6? Let's look at scenario number 1. Scenario 1. The mean is below 6. If the mean is below 6, that would imply that the sum of these 95 observations is going to be less than 95 times 6. Okay? Now, because I keep needing the room, so I'm going to again erase everything and talk about the second scenario. The second scenario is, scenario number 2 is, scenario number 2 would be, the mean is more than 10. In which case, the sum of these 95 observations is going to be more than 95 times 10, because 95 times 10 is 950, and of course if you divide something more than 950 by 10 by 950 rather, if you divide something more than 950 by 95, this is going to be something more than 10. So if the mean is something more than 10, even though we cannot tell for sure exactly what it is, if we can at least tell that the mean is more than 10, in which case the answer is going to be A. So let's start the work. I need the room, so we need to erase everything. if you're sitting there wondering why in the hell this question is in the exam if it's taking this long to solve it, well, there's a very straightforward and simple answer to that. It's because this question is not meant for mere mortal. This is a hard question. It is only meant for people who are shooting for something close to perfect score. People who are scoring 750 or above in the math portion. Somebody who is below that, somebody who is of the average caliber in the math, just pick an answer choice and move on. You're not going to win every battle that you're going to encounter. You have to learn to pick and choose your battles. There are some battles where it's fighting, and there are some where it is better to just walk away. And if you don't believe me, ask Kenny Rogers. He will tell you that you got to know when to hold and when to fold. Let's continue. And if you didn't know what the hell I just meant by Kenny Rogers, don't worry about it. So, we're going to figure out what the sum of these observations is, okay? It's got to be either, if we can figure out, if it is less than, again, if the sum of the observations is less than 95 times 6, then the mean is going to be less than 6. Or if the sum of the observations is more than 95 times 10, then the mean is going to be more than 10. That's what we're trying to figure out. And we're going to figure that out from here. But I'm going to start from this end. And I'm going to leave it up to you to follow the work with the book in front of you, because I am not writing everything there. So if you look at the graph carefully, you will see that we have 3 observations. We have 3 observations of 31. 3 observations of 31. Look carefully there and you will see. Now, when I said 31, I'm looking at a very conservative estimate. Very conservative estimate, because I'm assuming that every single observation that falls here, there are 3 of them, and I'm assuming that every single one of them is 31. So even in the most conservative scenario, these 3 observations, if they are every one of them 31, it is quite possible that all of these 3 observations are 35, because that is the very far end. It goes from 31 to 35 right here. 31 to 35. It is quite possible that all of those 3 observations are 35. It is quite possible that one of them is 31, the other one is 32, and the last one is 35. But in the worst case scenario, even if all of these 3 observations are 31 each, 31 times 3 will give us something approximately 100. Similarly, we have 5 observations of, I should put down the word at least 26. That will make it more clear, because we do not have 3 observations of 31, we have 3 observations of at least 31. That's 100. We have 5 observations of at least 26. 5 times 25 is 125, approximately. Then we have 10 observations. Then we have 10 observations of at least, now we are up to here, right here. Right now I'm working on this one. Let's call it 3. That one was 2. This one was 1. Okay. So I'm going in reverse order. We have 10 observations. If you look closely, it will say that we have 10 observations of at least 21. 10 observations of at least 21 gives us another 200. We're already up to 425 something. Let's do one more. Now we're up to here, number 4. We have 12 observations of at least 16. 12 observation of 16. 12 observation of 16. 10 times 16. 10 times 16 is 160. Another 16, another 16. 16 plus 16 is 30. Plus 160 is another 200. Watch what happens. 200 plus 200 plus 2 more 100. We are already above 625. We are already above 625. Let's find out what 95 times 6 is. I never did that, did I? I forgot. 95 times 6. 95 times 6 6 are 30, 9 6 are 54, times 3 plus 3 is 57. Voila, that's it. That tells us that because up to here we're only on the fourth one, and already the sum is approaching something more than 600, which is more than 570. So based on the work that we have done so far, it implies, based on the work, if we were to stop right now, let's say the time is running out, you've taken the exam, time is running out, you got as far as this much and that's all the time that you have. Based on the work that we have done so far, this implies that because the sum is more than 570, because the sum is more than 520, that implies that the mean, whatever the hell it is more than 6. It's more than 6. Which means answer cannot be, since it's more than 6, since mean is more than 6, the answer cannot be, had it been less than 6, the answer would have been B. It cannot be B. Also, it cannot be C. We have ruled out B and C at this point. Answer is either A or a D. The answer is going to turn out to be A if we establish that the mean is something more than 10. In order for the mean to be more than 10, this sum would have to approach something more than 950. If this sum approaches more than 950, then we know that P average is more than 10. The answer would be A. If this sum turns out to be something less than 950, we already know that it's more than 570. So if it's somewhere between 570 and 950, then the answer is going to be D, because we cannot tell what the mean is. The mean is somewhere between 6 and 10. We'll see what happens. Let's continue. Let's continue. I need the room. So we have 15 observations. 15 observations. Now we are up to here. 15 observations of 11. 15 times 10 is 150, plus another 10 is going to be about 160. Let's just say 150. Then we have 35 observations. 35 observations of at least 6. 35 observations of at least 6. So, where were we here? We were at 625 here. We were at 625 plus the 150. That gives me another 800. That gives us approximately 800. 35 observation of 6. 3 times 6 is 180. So that's another 200. That is already more than 1,000. That's it. That's already more than 1,000. We don't have to do the exact calculations. Just approximately is good. The sum of this 95 observation is going to be more than 1,000. And since the sum of these 95 observation is more than 1,000, since the sum is more than 1,000, therefore mean is going to be 1,000, which is their sum, something more than 1,000 over 95, which is going to be something equal to more than 10. Something more than 10. So the mean, now we establish, is something more than 10. Median, we know, falls somewhere here, which means the median is either 6, 7, 8, 9 or 10. Mean, whatever it is more than 10. And since the mean is more than the highest possible value of median, therefore the answer is A. That's it. Therefore, the answer is A. That's all. Just give me one quick second here. I want to do something here before we stop this thing here. There we go. The answer is A. That's all. I got paranoid at the very end because for some strange and inexplicable reason, in my notes, I had written down at the very end, then the answer is B. The answer is not B. The answer is A. The mean is going to be more than 10 because the sum is already more than 1,000. Something more than 1,000 divided by something less than 100 has got to be more than 10. Notice how I spoke? The fact that it is 95 at this point is irrelevant. Something more than 1,000 divided by something less than 100 is going to be more than 10. It's going to be something more than 10. The answer is A. That's all. We're done. Finally. I could have, of course, done done this very problem very superficially, very quickly, and just for the sake of doing the problem. And I could have done that with every single problem that you've been watching in these videos. But I like to make sure that we're not solving problems just for the sake of solving problems, but we are solving problem for learning purposes. Don't worry about how long it takes. Even if it takes you half an hour to do a problem, it does not matter. Right now, we're doing it for the learning purposes. Learning comes first, and then you worry about the speed. Let's first learn how to do these problems before you worry about how fast you're doing them. You understand? Anyway, I'll see you tomorrow on day number 53. Okay? Bye now.